In this segment, I want to talk about how lists are built, how they're constructed, also how they're taken apart, how they're destructured or deconstructed. Well, a list in Haskell is either empty, which we write open square bracket, close square bracket, or it's non-empty, which is written between square brackets with the elements listed in between. And a crucial point to understand is that if you have a non-empty list, you can decompose it as an element stuck on the front of a list. Here we have 3 stuck on the front of the list 2, 4. And let me just say a tiny bit about terminology before we move on. We use the word cons for the colon because it constructs a list. So we'll say x cons x's. And we use a single x because we know there's a single element comes before the cons. And we say x's afterwards because that's a collection, that's a list of things. And so we're reminding ourselves that with an x in front, it's a single thing. With x's afterwards, it's multiple things potentially. It could be none, it could be one, but it could, in principle, it will be many things. And so typically when we write a pattern for a list like this, because it is a pattern, we'll write something like y before the cons and y's afterwards, or z and z's, and so on. So if we think, first of all, of taking the list 3, 2, 4, we can decompose it like this. We can say, well, that's 3 cons the list 2, 4. 3 stuck on the front of the list 2, 4. But we can do the same thing to that list 2, 4. And so we get 3 stuck on the front of 2, stuck on the front of list 4. 3 cons, 2 cons, list of 4. And we can do that again with the list of 4. So it's 3 cons, 2 cons, 4 cons, the empty list. And we've got brackets proliferating here. What we can do is we say that cons is right associative. So when we write 3 2 4 empty list, that means 3 cons brackets 2 cons 4 cons empty list, and so on. It associates to the right. When there are 2 conses, we put the brackets around the cons to the right. So when we see something like 3 2 4 empty list, that's the list 3 2 4. That's how it's built up. When we write it down, the list of elements between square brackets, that's a shorthand for this way of building up the list. And let's just remind ourselves of that again. We can think of building this. We start with an empty list, we cons 4 on the front, and then we cons 2 on the front of that, and then we cons 3 on the front of that. So we can see it being built from the empty list that way. We could also start with the list and decompose it using pattern matching. And it results in building the list by successively adding elements at the front of the list. And that gives us our list 3 2 4. Just one final thing. I've said that lists can always be seen as having either a head, either being empty or being non-empty. That allows us to write simple definitions by pattern matching over lists. So we have a function head that takes a list of A and returns an A, because that takes the first element off the list. We have the tail, which removes the first element, if you like. It returns everything but the first element. And the idea is every list is built up by consing its head to its tail. And we can write a function that tells us whether or not a list is null. We're doing that by pattern matching either the list being empty, in which case the answer is true, or it's non-empty. Now there you can see we've used a wildcard in both fields. All we're interested in is that it's built using cons. As soon as we know that null must be false. So in this segment we've understood that lists can be built up from the bottom by adding elements to the front of an empty list, Alternatively, we can successively decompose a list so that we get down to the empty list. And we'll use this in the next segment to think about how to write a recursive definition of the sum of the elements of a list of integers.